With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question is the total number of structural dihaloderivative possible in n-pentane are. We have to tell that how many total structural isomers of dihaloderivative of n-pentane are possible. So n-pentane is 1, 2, 3, 4 and 5. So this is our n-pentane. This is n-pentane, and we have to tell that total number of structural isomers of dihaloderivative. That means two halogens are present in n-pentane. So let us say let the halogen be X. Okay. So now let us draw the structures, or you can say structural isomers. So we have a 5-membered chain of pentane to which both the halogen atoms are attached to the same carbon. So suppose if we'll attach both the halogen atoms to this carbon, that is carbon number 1, then we will have one structure, and if we draw the halogens, both the halogens here, then it will be another structure, and if we draw this here, so it will be a third structure. But if I put these halogen atoms here, then this and this structure will be same, and if I put both the halogen atoms here, so this and this structure will be same. So the total number of structures that we are getting here in this, where both the halogen atoms are attached on the same carbon, are 3. Now moving on to the next one, that is I am attaching the halogen atoms on different carbons. So I am attaching this on these carbon. Okay, so here we are having, that is on adjacent carbons I am attaching the halogen atoms. So we can attach it on this carbon. That means one structure is this. If I attach these both carbons here, then it will be similar to this structure. So now can I attach both the halogen atoms on second and third position? So if that means one more structure, that is, let us say this is 1, 2, 3, 4 and 5. So if I attach the halogen atoms on 1 and 2 position, or if I attach them here, then numbering will start from here, then it will be same, that is the halogen atoms are attached on 1 and 2 carbon. So one structure is on 1 and 2. The other one can be that it can be on second and third position. So it will be on second and third position. Either I can attach it on second and third. So the second structure is this, or I can put the halogen atoms on these carbons. So numbering will start from here 1, 2, 3. So again it will be on second and third position. So here we will have 2 structures. Okay, now moving on to the third structure, where I am leaving one carbon and then attaching the other halogen atom. So here we will have 1, 2, 3, 4 and 5, and I am attaching one halogen on the first and leaving one carbon and then attaching one here. So that means this is 1, 2, 3, 4 and 5. Okay, so in this case, if I put halogen atom here and then another one here, that here, or you can say I am putting the halogen atom here and then putting another one here, then numbering will start from here 1, 2, 3 and 4. So again both the halogen atoms will be at first and third position. So one is this structure, and the other one can be carbon, carbon, carbon and carbon. I am attaching it at second position and leaving one carbon and then attaching it at fourth position. So what will happen is, if I start numbering from here, then also the carbon atoms will be at second and fourth position, or if I start numbering from left hand side, then also the halogen atoms are on second and fourth position. So one structure is this is one and this is one. Now moving on to the next one. So moving on to the next one, that is, I am leaving 2 carbon atoms here. So I am leaving 2 carbon atoms in between first, second, third, fourth and fifth. So what will happen is, this one halogen 1, 2 and 3 and 4. So what happens is, if I draw the structure here, this is at 1, 2, 3, 4 and 5. So what happens is, if I draw the structure here, it will be one. If I start from 1, the halogen atoms are at first and fourth position, and if I start this, I will put this halogen here and this halogen here, then also the numbering will start from here, so it will be at first and fourth position only. So it will be same. Now moving on to the next one, that is carbon, 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 carbon and carbon. So I am putting it on the second position, and if I put it on second position and the other one leaving 2 carbon in between, then again it will be first and fourth position. So this structure will be similar to this structure. So here we will get only one structure. So let us count the structures here. That is 1, 2, 3, 4, 5, 6, 7, 8 and 6, 7, 8, and one more structure will be there. That is, so it will have 9 structures in total. That is 3 here, 2 here, 5, 6, 7, 8 and one more structure will be there. One more structure will be here, that is, both the halogen atoms are attached at the terminal positions. So it will one more structure. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 structural isomers are possible in dihaloderivative of n-pentane. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.